Okay, when you're solving exponential or logarithmic equations, the whole idea is once you get the base numbers to be identical, then you set the exponents equal to each other and solve like you would a basic simple equation. So here's an example. So number 3, 5 is raised to the 2x subtract 3 is equal to 125. Well, 125 is a power of 5. 125 is 5 cubed. On the other side, we have 5 raised to the 2 minus 3x. Well, once these base numbers are the same, you can ignore them, and you set the exponents equal to each other. So 2 subtract 3x is equal to 3. Well, that's kind of a no-brainer. We're going to subtract 2 on both sides. You could have done it the other way. You could have added 3x and subtracted 3. So now we have negative 3x is equal to 1. And then, you got it, the inverse of multiplying negative 3 is divide negative 3 both sides. And x equals negative 1/3. It's always a good idea to check your solution to see if that works. So if we say 5 to the 2 subtract 3 times negative 1/3, well, negative 3 times negative 1/3 is positive 1. 5 cubed is equal to 125. Well, 125 is also 5 cubed, so that answer does check out. Okay, I'm going to cover up this one. So you might want to pause it if you need to take the notes. And here's another one. Well, remember what we said about fractional exponents. What that fractions, that means exponents. So you could rewrite that as 64 to the negative first. That means the same thing as 1 over 64. But because we're doing powers, there's a couple things that we need to do. We could rewrite that as 8 to the negative squared, and then to the raised negative 2x subtract 3. And on this side, we have, 8 to the raised negative x. But what I want you to get in the habit of identifying, 8 is the power of 2. So I want to rewrite 8 as a power of 2, and I want to rewrite 1/64 as a power of 2. So 8 is the same thing as 2 cubed, and then that would be raised to the negative 1x. Okay, so I think I did all of this. There we go. And 1/64 is going to be 2 to the negative 6th. If you type 2 to the negative 6, you'll get a decimal. If you hit second, PRB, you'll go ahead and get the fraction. All right, and what did we say is the power rule with exponents? When you raise a power to a power, yes, you multiply. So on this one, you do the distributive. This one, it's still distributing. It's just over 1. So negative 6 times 2x is negative 12x. Negative 6 times 3, I knew what I was missing. There's a negative 2 right there. So negative 6 times negative 2x is 12x. Negative 6 times negative 3. So now we have 2 to the 12x plus 18. 2 to the negative 3x. Well, these base numbers are now the same. So you can set the exponents 12x plus 18 equal to negative 3x. And then I'm going to choose to, since 12x is positive, I'm going to choose to add 3x. That zeroes out this side, but then I'm going to subtract 18, both sides. So 12x plus 3x is 15x. 15x is equal to negative 18. The last step is the inverse of multiplying 15 is dividing. So when we divide, well, negative 18 and 15 both have a 3 in common. So x is equal to negative 6/5. Then you would plug the negative 6/5 into both of those equations to check to see if it's true or not. All right. Cover that up so we can focus on the next one. The next one, I think, Should have done this one second because that's an easier one. Look at those base numbers are already the same. So we can just set this exponent and this exponent phrase equally to each other. All right, so because this is negative, I'm going to add 3m to both sides. And since I'm getting rid of the m's on this side, I'll go ahead and add positive 1 to both sides. So then we have 6m, negative 2, well, that can't, whoops. That cancels. Negative 2 plus 1 is negative 1. And then the last step, you'll divide 6, both sides. That cancels. And so m is equal to negative 1/6, and then you'd go ahead and check your answer. All right, that's it for this one.